in this problem we have a truck, which is the mass of 2, that is pulling a trailer that is mass 1. And we are to find the tension that is in between the truck and the trailer. So the first thing I want to mention about a problem that has wheels, say like a car or anything like a cart, is that the friction is pointing in the direction of the velocity of the larger mass. So the velocity of the truck and trailer is going to the right, and because of the wheels, the friction is also going to be going to the right. And that's because of the torque in the wheel. If this is the ground here, and you have the torque going around in this direction, the velocity at this point wants to go this way, although it is a static problem, because unless you're skidding out, there's not going to be a relative velocity here. It's going to equal 0. But the velocity wants to go in this direction. And as we've learned before, in between the point of contact, and even in a static problem, where the velocity wants to go, the friction is exactly opposite. So this is the friction. However, because of this torque, the mass of the object, the acceleration, is going to be going to the right. And this will be 1/2 of this A. So the very top point is going to have the exact opposite acceleration because of the torque, and in the middle it's going to be half that velocity because it's half the distance. So when you look at a problem that has wheels and it says there's a friction, you put the friction along with the velocity because of this unique connection. And the unique connection, even though there's motion, it's a static friction. And I imagine that's why they've given you the value of friction rather than the coefficient of friction. Because if they just gave you the coefficient of friction, this problem would be a lot more difficult because you'd have to break down the wheels, recognize that it's a static, even though there's motion. So be thankful that they've given you the value of friction because it does simplify the problem a little bit more. Okay, now let's get down to the actual problem. This is the first problem that we have the forces and acceleration in the same problem, so that's pretty exciting. We're finally getting somewhere. And when you look at a problem like this where you know that you're finding the tension in the middle, usually you're going to look at the system as a whole and then one part. And this is similar to truss problems that we've seen before where you look at the whole system and then you start breaking it down. So there's going to be 2 sets of free body diagrams for this problem. And this first set, we're going to have the 2 mg's, and I think this is m2g, m1g, and 2, and 1. And there's only one force in the x direction. So that tells us that we can also find the acceleration in the x direction because the friction is going to be directly associated with that acceleration in the x direction. So, whole system. Sum of the forces in the x direction equals mass times acceleration. When working force and acceleration problems, I like to break it up in half, and on this side there will only be friction. On this side, there will only be acceleration equations. This is the mass total, and that will be m1 plus m2. And this is only going to be friction. We know friction, we know the mass, now we just have to find the acceleration. And the friction will be positive because it's going in the right direction, and that will be m1 plus m2 equals A, and that is total. And let's just put AX to remind us that it's in that direction. So 20 kilonewtons, and that is 3,000 kilograms A. And therefore, A is equal to 0.667 meters per second squared. And we know because of the connection of block A1 and A2 that the acceleration in the x direction that we just solved for equals the acceleration of x1 and x2, because there's not a relative acceleration between block 1 and block 2. Alright, now we have that, and we know now the acceleration of block 1. This is block 1. So let's find now everything about block 2. Because in order to find the tension in the rod between the two blocks, we have to break it up. Because that's a 2-force member, you can do that with a 2-force member. So mass 1. We have the block, tension, and we chose the block 1 because we don't have to deal with friction. It just reduces a force. You could, if you wanted to, look at block 2, but we've chosen to do block 1. And once again, I'm going to break it up so you're only looking at force equation on this side and only looking at acceleration on this side. And on the left, there's only tension, but on the right, we have the mass of the object 1 and 2. We know acceleration of A because we just solved for that. Mass of 1 is given. Now we can solve for tension. And that tension equals 2,000 kilograms times the acceleration. And that ends up being 13.33 kilonewtons. So now we have solved for the tension, which is the force between the two blocks, by looking for the acceleration. Because this is a kinematic problem, no longer can we just say that this is equal to 0 and solve for forces on the left side.